All right, nuclear physics. Wait, proton beam with a what accelerator?
Oh, you can, like what the one that they use over there in CERN in Switzerland can make.
Oh, the big one, the
beams.
super
They got some
collider.
at Los Alamos that do it too.
That's a super collider.
That's a big particle accelerator. The super collider was a plan that they
that was in
nixed
Texas.
After they spent a lot of money on it, then they killed it.
Oh, they didn't actually
look,
finish
God's
that
over
one.
there.
Huh?
Look at all those rays, like from the clouds.
Oh yeah.
Those are the shadows of the clouds.
Oh.
And they're disappearing, like they're actually horizontal and they're disappearing into the perspective, like toward the, the vanishing point and the perspective projection that our brains make.
Is there a sundog?
Yeah.
No, I don't see a sundog.
Always amaze me, like, because they're really spreading out, but they look like they're coming together.
Oh, it's doing something funny to the lens.
Yeah.
The lens has it's doing something to the lens.
Are we getting close to the edge here, creating those effects like
the Twilight Zone?
The one that paints the moon.
Should dub in some.
I do think that probably
breaking
is
glass.
The camera. I've been thinking about that a lot. I think that probably is the camera.
That's a UFO. No, it's lens flare.
Lens flare.
It's always lens.
This is a planet swap gas.
I'm not moving the camera, but it's moving.
Yeah. Oh, God.
If something's moving and the camera's staying still, it's not lens flare. It's just out there. Something's out there.
Well, what I thought was possible was...
Now let's talk about nuclear
that
physics.
you'd have to eliminate the
stay
camera by, like a rigorous set of tests before you can say that it's not the camera.
It's impossible, because your eye is a camera.
Well,
it's impossible to get rid of the lens.
Well, what I mean is that, like the camera would only refresh if something moves. If you're taking a picture of the moon, it's only when the shadows change enough, like it's going to trigger it to refresh the frame.
Mm-hmm.
And, like that's what ordinarily, digital images or, what you call it, television images, like they have to be refreshed because you got a picture and then you got another picture and you got another picture, like it's not one continuous, flow, or, anyway, it isn't the way we see it, It's a lot of little snapshots.
So let's get back to the nuclear physics, because
oh, yeah.
we have in the core in the nucleus you've got protons and neutrons.
Yeah,
but what is the difference between a proton and a neutron?
Yeah. Okay.
A neutron doesn't have a charge.
That's
a
right.
proton is
That's right.
Is
so
positive.
Somehow they got an electron inside it. That's
an
the
electron,
only way that I can think of.
Well, an atom has to have an electron, doesn't it? What's one electron? One shell.
Well,
that's helium.
No. Helium is an atom which is like an alpha particle. It's got 2 neutrons and 2 protons and 2 electrons.
2 electrons?
Yes.
What if it only has 1 electron?
If it only has 1 electron, then it's a hydrogen atom.
Oh, okay. I'm sorry.
Or it's an ionized helium atom.
Does hydrogen have the same nucleus?
An ionized helium atom would have one of the electrons or both of them pulled away from it. You see, that's what you call an ion. It's like a nucleus that has been
altered. An ion is not, but that's not stable, is it?
No, an ion isn't stable, but like an ion exists, like and there's potential between ions. So they exist in liquids and
what's
stuff like
ozone?
That.
Ozone is an
O3.
oxygen with an extra.
Well, it's,
how does it do that? How does it join with another?
There's something called covalence. Ordinarily, hydrogen, oxygen, nitrogen, and like probably a couple other gases form molecules of 2 atoms each, and they share electrons.
Oh, those are noble gases.
Well, no, those are the noble gases are helium.
Why are
neon,
they noble? Why are they noble? Those were
krypton,
the ones that...
like radon. It's a radioactive noble gas. It's because it won't form, because it has complete electron shells, so it won't form covalent bonds with anything.
Oh, okay.
You see.
Yeah,
I mean,
you just
electrovalent bonds, excuse me.
So oxygen is not a noble gas.
Yeah, covalent bonds are where these electrons surround both the nuclei.
Yeah.
An electrovalent bond is one where one of the electrons has been pulled over and is in the shell of the other atom. you see, and this causes them to form a crystal.
Oh.
There's a structure in it, see, those electric forces build up these fantastic, geometries.
So how do they move? How do they vibrate then if they're a crystal?
Well, they vibrate at particular frequencies, depending on what the substance is made of, what its mass is, how much energy is involved.
It changes its behavior.
Yeah.
So the ozone.
And so that's a compound. You see, that's
Will the ozone readily give up that electron to cause ozonation?
What will happen is
what do they call
it's
that?
unstable. So
it's unstable.
It's unstable. So it will turn into O2, into oxygen, and then there will be a free radical atom of oxygen without a mate, and it's hungry, it's horny. It wants to go out and get some. So it goes out and burns everything that it touches.
It burns. That's why when I breathe that ozone, it burns.
That's right.
What is it doing when it burns?
When it burns, it's just burning
oxidation,
it up.
Isn't it?
Yeah, it's oxidation. It's oxidation at the primary level.
What does that do to metal? It rusts it.
Oh, well, yeah, or it combines in other ways.
What is resistant to that? What can resist that?
Probably things that don't rust. Stainless steel is probably resistant to it. But it's also useful, like they put chlorine. It does the same thing if you put chlorine in water, like Clorox and stuff. Like what you do there is that you create.
Oh, that breaks down the bonds.
Yes, it's the same thing. So you got this hypochlorous acid.
Yeah.
And so you got this
Acids.
ClO3 on the end, and the O3 breaks off, and one of the, it turns back into O2.
What if we could create
and you got all this hydrochloric
nuclear
acid
acid blast explosion? Just dissolve everything within contact of an acid blast.
Well, a whole lot of ozone would probably produce a hell of a fire. That would probably be.
That's what they thought. That's what they thought when they were doing that. They set off Trinity, and they were hedging their bets. What would happen?
There was a lot of people that were worried that it was going to start a chain reaction and other stuff.
Burning everything.
Yeah, because it was going to be so hot.
It was going to get so.
Because it was going to be much bigger than any reaction that they had
so
produced.
If you create a substance that would just, like antimatter, that would just continue chain reaction.
Well, they say that antimatter would do that.
But we don't think that just by splitting an atom there's an antimatter.
No. They exist. Apparently
radiation.
They think that I've heard that people think that they have created it, but positrons and stuff, I still believe is in the realm of unproved science fiction.
Okay, so we're talking about that. But what about neutrinos?
Now, neutrinos is a similar kind of thing, what
they
the hell is a neutrino?
Well, they say that they can see them when they do one of those tests, those prints. Don't they show up on the
I don't think they show
like electron paths?
Yeah, I'm not sure what they show up on, but neutrinos can penetrate deeply, like you try to find them in deep wells. They look for a lot of that stuff in deep wells because there's so much that would stop stuff. And these
How are you going to find a
stop.
neutrino? Because, for instance, the description is that they pass through matter. They're coming out of the sun. The source of neutrinos is the sun.
Well,
I didn't hear that they come from anywhere else. If they're
they
streaming out of the sun, they're so small that they just go through everything else at a certain speed. I guess it's
generally when you talk about neutrinos, you talk about something that goes, like a lot of people would say, well, it's an electron and a positron make a neutrino.
So it's questionable. But what about subatomic particles? Do they have any?
Well, the subatomic particles are neutrons, electrons.
No, no beyond that.
But then you go to quarks.
Quarks.
And then you go to Higgs-Boson, which won't explain to me. They refuse to explain it to me.
No. All right, that's how we're going to have to end this because the Higgs boson is not. We cannot explain it.
Well,
they proved it.
It's been manifested.
It's the God particle.
Yeah, apparently they did it at CERN. That's what they claim. Boy,
You-
this light just keeps going and going.
Well, you think that CERN is really where they got that info?
Oh, that's a cool one too. That long
Is
cloud
it
there.
the Higgs boson?
Oh, look at the chocolate. Look at the color of the mud mountain. You know, like with that red.
Oh yeah, there's some really bright colors over here.
Yeah, that's arty.
Yeah.
Pretty cool. Yeah, it's just
So we
such a
don't-
different color over here. It's a lighter blue.
We don't want to say anything about the Higgs boson to sound
I don't
intelligible.
know anything at all about it except that they use this gee whiz,
It's
damn expensive machine, like to
it's a
create
substance that cannot be affected. It's
Well,
underneath.
The original meaning of atom for the Greeks was that you can't divide it any further. So when they divided the atom and produced atomic energy, that definitely
Okay,
blew
no,
apart
they-
this
so
whole
they
idea
said-
of reality.
So they said no, but which
Yeah.
Greeks said that? Because some of them believe that everything was derived from water, and some believe that everything was derived from air. Remember, I don't remember the name of the school of thought, but
it was
is that
just that
everything was a permutation.
I think it was
of
just
air.
the logic that there was
So
something
those
that
atoms.
you couldn't break down. That there was
Were
some
they trying to say that?
ultimate thing that you couldn't break into.
Right, you couldn't break it, but like
Yeah.
like rock here, they would say that rock was really just like a coagulation of a certain amount of air atoms that bond and then form this. Everything can be broken down. That there's a basic atom,
Well,
and however many you put together creates
well,
different.
I don't
types-
suspect that they
types.
knew an awful lot about the inner chemistry of stuff, like in the electric. They were interested in electricity. Electrum, like in.
I'm sure that they
yeah,
were. I
you know,
mean,
like
because you
the
could
words come from
if
there.
they observed and
Yeah.
saw lightning bolts.
Yeah.
I mean, they were like
But then
saying
they got
it was
into
something.
the kind of static electricity where you get the little crackles and pops when you pet a cat, or if you have a glass rod and you rub it with flannel,
they felt that.
and all of those kind of things.
And they were like, "What?
And
What
they
the
discovered
fuck is that?"
They found the polarity of electricity.
Mm-hmm.
They discovered that there was polarity, that there was attractive electricity and there was repulsive electricity.
Mm-hmm.
you know.
Different properties of electricity.
Yeah.
Well, of course we've got to talk about electric. And is there any electricity involved with a nuclear explosion?
Yeah,
Nuclear
there's a tremendous amount of
atomic?
magnetism. Magnetism and electricity, or electromagnetism, are the function of electrons being moved. And when electrons move, they produce a magnetic field.
They vibrate together and create a magnetic field.
Yeah, every time an electron moves, it produces a magnetic
It's
field.
electromagnetic.
The magnetic field is a sense of the sensing of the motion of the electron.
Yeah.
And the other way around is that
You can measure that.
yeah,
Everything has a different
Faraday's
measurement
equations.
of the field. Faraday? Yeah.
No,
Michael Faraday?
no. Excuse me, Maxwell.
Maxwell.
This is Maxwell.
Oh, Maxwell.
Yeah. James Clerk Maxwell did this. Like Faraday was the guy who worked with it extensively.
Okay.
Yeah.
Yeah. And these are the forces that are released when you split. So you cause the reaction to detonate the like a hydrogen bomb.
Yeah, the stuff that comes out of
Hydrogen
it.
bombs.
Yeah.
Now we've got to talk about how they've tampered with this. First, it was heavy water, right?
Yeah.
That
it's
was
got neutrons
the
on
British were working on
It's
that.
got neutrons on
And the
the
British program
hydrogen in
got
the water.
defunct somehow, and they said the Germans had it. Then they went into hydrogen, and then the uranium was getting enriched.
Yeah.
They were refining the uranium, all right, after they discovered that. But originally they were going with heavy water. So let's explain
like it,
how.
Yeah. I don't
What
know
were they-
I don't know what course they were following. I don't know anything about the Nazi science involved.
So you don't know how they would
Yeah,
create
all
an
I know about
explosion
is
from the
Niels Bohr
heavy
and
water.
Enrico Fermi and all
They were
those guys.
super saturating the water or something.
Yeah, but
So when they actually came up.
you accumulate it. Like there's a certain amount of it in the water, and so you accumulate it, and you do it just like you do the uranium. Like you do it by mass.
It's like dense water.
A centrifuge or a series of filters, ceramic filters, so that the heavy stuff ends up in one end and the light stuff, like a sluice box, like if you're panning gold, or
Yeah,
you know what I mean.
yeah.
And that's the way that it's separated out. So it takes a humongous amount of effort, I tell you,
So when they came up,
the British commandos, you know, like are really proud of the way that they sank that factory. You know, like they made a movie about, you know, keeping on bombing the place. So they put it on a barge and then they sank it in the lake, and I think that was the end of it. You know, I think the Germans gave up after that. At least that's the story that the Brits tell. You know, the fires are low and the wind is from the north.
so tell me at the end of this now, because this is a long video. No, let's go to a new video.